Hey everyone, today we're going to be starting a new unit on functions. Last night you reviewed some of the basics of functions. You identified a function and basic evaluation. Today we're just going to go into a little more depth on that. So we're going to start by just reviewing some vocabulary you should already know. A relation is any set of ordered pairs. A function is a relation such that every x is assigned one and only one y value. Functions can be expressed as tables, ordered pairs, or rules, which is really just an equation. The domain of a function is the set of all x values or input values. The range is the set of all y values or output values. So the first thing we're going to start out is with evaluating. And in order to evaluate a function, just plug the x value into f of x. We're just going to substitute. So if I give you something like the do now, if f of x equals 2x squared minus 3x, then evaluate the following. This is all function notation. So f of 3 just means, f of 3 just means plug 3 in for x. And then we're just going to do a little math there. So I have 18 minus 9, and my answer is 9. And that's your output value. In the next example, we're going to do f of 3x. So every place we see an x, we're going to plug in 3x. And when we go to evaluate this, just be really careful because this is 3 squared. So 3 squared is 9. 9 times 2 is 18. X squared minus 9x. And I just want to point out here, since we plugged in an x, we're going to have an x in our answer. Example C is 3 times f of x. So now look at where your multiplier is outside the function. So we're going to take 3, and now we're going to put our function in there, and then we distribute that 3 and get 6x squared minus 3x. Again, I want to remind you, since we plugged in the function, we're going to wind up with x's in our answers. The next one's a little tricky. We have f of negative x. So every place I see an x, I'm plugging in negative x. And negative x squared is just x squared. So this becomes 2x squared. And now in the next term, I have a minus. So I change that to a plus. For the next example, we want to negate f of x. So we're negating the actual function. Again, here you want to be very mindful of putting parentheses around the entire function. And basically what that's going to do is we just negate each term of our function. For part F, we're going to plug in x plus 3. So every place we see an x in the original function, x plus 3 squared minus 3 times x plus 3. We're just going to substitute, just like it would be a number, but it's just x plus 3 now. Here's where a little work has to get done, because hopefully you guys remember this is really x plus 3 times x plus 3. So I'm going to have 2, FOIL this guy out, x squared plus 6x plus 9. Now in the next part of this problem, I'm going to have to distribute this. So I have minus 3x minus 9. Now I want to distribute the 2, and then I'm going to clean this guy up, and I'm going to run out of room. 2x squared plus 12x plus 18 minus 3x minus 9. And when we combine like terms, our final answer becomes 2x squared plus 9x, and 18 minus 9 is plus 9. So that would be your final answer there. For these next two examples, G and H, these are going to seem very, very weird to you at first, but this is something that we have to get used to doing. I'm going to write my function down here so I don't have to keep scrolling. 2x squared minus 3x. Okay, so for part G, every place I see an x, I'm going to substitute x plus h. So this is going to become, I'll go down here, 2 times x plus h squared minus 3 times x plus h. Now we need to work on cleaning up this guy. X plus h squared, this is something you're going to get very used to seeing. X plus h times x plus h. So this piece here, we have to FOIL this out. I want to point out right now that it's not going to matter if I FOIL it today, if I FOIL it tomorrow, next year, whatever the case may be. You're always going to get x squared plus, I have xh and xh, that's going to become 2xh's plus h squared. And then I don't forget about the rest of it, minus 3x minus 3h. My last step here is going to be to distribute 4xh plus 2h squared minus 3x minus 3h. And there you have your final answer. Okay. So now in our last example on this page, we want to find f of x plus h minus f of x over h. Now this is going to seem, you're going to be like, why are we doing this? This is something special in calculus. This is called a difference quotient. So this year, I like to try to introduce this to you and get you in the habit of setting this up. Now, the good thing about this is part of our work is already done because we have to find f of x plus h. We already did that in this example here. So what I'm going to do is I'm going to substitute f of x plus h, what I just found, up on the top left part of my numerator. And then I'm going to subtract f of x. And f of x is our original function. So now I'm going to go back and I'm going to subtract f of x. Now, after this first example, I'm pretty sure you're going to take a little shortcut route, and that's totally okay. I just wanted to kind of show you. This is your f of x plus h, and the second term, the second set of parentheses is f of x. So now if I clean this numerator up, h, meaning I subtract and I change my signs there. What you're going to notice is you're going to have some terms cancel out. For instance, the 2x squared is going to cancel out with that negative 2x squared. My negative 3x and my positive 3x's are going to cancel. And we're going to be left with 4xh plus 2h squared minus 3h over h. And again, here there's going to be a special step. If you notice, I have an h in each term in my numerator. I'm going to factor that out. And those h's are going to cancel. And my final answer is going to be 4x plus 2h minus 3. It's going to seem very, very weird to do this at first, but please just make sure we're going to work on it more as the year goes on. That's just something you definitely have to know how to do for next year. In this course, we're also going to focus on identifying the domain of functions algebraically. I know you studied this already in Algebra 2. We're just going to carry on with what we studied in Algebra 2 and work on the algebra part a little bit more. So when we're thinking, when we're trying to find the domain of a function algebraically. We think of the domain as the largest possible set of x values. In other words, the real numbers, all of the numbers. And then depending on the function, we may have to restrict the domain at times. Okay. So always think what the function is first, what type of function it is, and is it ever going to not get answers? So in part A, if I want to find the domain of this function, I think, all right, so f of x equals 2x minus 4, that's a line. Is there any x value that I'm going to plug in and I don't get an answer? No. Okay. So the domain of this function is all reals. We could also represent it using interval notation. But for the most part, if I ask you to write it, you can write all real numbers, just like that. Our second example, part B, f of x equals x squared plus 5x. Again, think about what this function is. This is a parabola, right? In a parabola, I always, whatever value for x I plug in, I get an answer. There's nothing stopping me from getting an answer. So once again, my domain is all reals. Now in C, g of x equals 3 over x squared minus 4, we know what? We know that in the past, from our previous courses, if our equation has a denominator, we have problems. There's places where it's undefined. Specifically, it's going to be undefined when the denominator equals 0. So to find the domain of this function, we set the denominator equal to 0, we solve, and then we exclude those values. These become sometimes what are called restricted values, if that makes any sense whatsoever. But we just describe it as x can't equal. So we go back over to our function. I'm going to set the denominator equal to 0 because I want to find the numbers that make the bottom 0. So if I was to plug in a -2 or a 2, I'm going to be undefined. So the domain, you could write all reals if you want. X can't equal plus or minus 2. X can't equal 2. X can't equal -2. Either answer is really acceptable in my eyes. For part D, D is a square root. And when you think about evaluating square roots, where's our issue? Okay, our issue is no negative under the radical sign. So when we're trying to figure out the domain for a function that has a radical sign, you set the radical, like whatever's underneath there, greater than or equal to 0, and then you solve it. Because I'm restricting my values to values that are going to give me positive numbers under the radical sign. I'm just going to flip my sign in a minute. I'm going to add that over, divide by -3. So t is going to be, remember, when you divide by a negative, you've got to flip that sign. So the domain in this function, right, we're going to write it as x is greater than or x is less than, depending on what happens when we're solving. In this case, we got t is less than or equal to 4/3. And that would be your answer. It's a little messy there, I'm sorry. So with h of x here, what's our problems? Now I have two things going on. I have that radical, so I have a numerator and a denominator, so my denominator can't be 0. But I also have a radical sign in the denominator, so I can't have a negative. So what I'm going to do is I'm going to set the radical strictly greater than 0 to account for that. So I take what's under the radical sign, strictly greater than 0. 2x is greater than -3. divide by 2, x is greater than negative 3 halves. Once again, just be aware of this. You're going to write your solution set, or your domain is going to be written as an inequality. So my domain here, x is greater than negative 3 halves. Okay, so it's pretty easy stuff. For part F, and that's again just a square root sign, so we do greater than or equal to 0. So under the radical, greater than or equal to 0. And when you go to solve this, you have to remember how to solve quadratics, which was very, very way in the beginning of the year now. So remember, in order to solve a quadratic, find the zeros. So we set it equal to 0, which means I'm going to have to factor. So all of your years of math are coming back into play right now. So the values that make this 0 are x equals 4 and x equals negative 1. When we're solving the inequality, we put them on a number line. These are our x-intercepts. Negative 1 and 4. And then we go and we use our inequality sign to help us finish and find the solution set, which in this case is going to represent the domain. Greater than or equal to 0. I'm using closed circles. And when I have greater than, I shade out. My solution set is that. So x is less than or equal to negative 1, or x is greater than or equal to 4. We could also represent this in interval notation. So this is just negative infinity to negative 1, which negative 1 is included, union 4 to infinity. Okay. So there's a little domain review. And the last thing I want to talk about today is our basic operations we can do with functions. Like anything else in math, we can add, subtract, multiply, and divide. So we have to understand how to read the function notation and apply that when we're given functions. So if I have f plus g of x, that just means I'm adding my two functions. F minus g of x, I'm subtracting my two functions. F times, we're multiplying. And then we can also set up division with functions. And we need to remember that when we have, when we're identifying the domain at the bottom here, when we're writing the rule for a division, we can't have a 0 in the denominator. So we have to be aware of that. In this example, we're given f of x equals x plus 2 and g of x equals x squared minus 4. We just want to find each solution. It's not really finding a solution. We're just actually doing the operation. So for the first example, I'm going to write this out. Okay, f plus g of x really means f of x plus g of x. And I know we're going to take shortcuts. F of x is really just x plus 2. G of x is x squared minus 4. So we're really just combining any like terms that we can. X squared plus x, 2 minus 4 minus 2. So we're just writing those two functions as simpler, in standard form and cleaning things up when we can. F of f minus g of x, well now I'm going to take my f of x and I'm going to subtract g of x. Again, I know you guys are going to start writing that first step, stop writing it after a while, but remember what you're doing. So f of x minus g of x. Now remember, I'm subtracting the entire function. So I have to remember to distribute that negative sign. And the answer here is negative x squared plus x plus 6. F times g of x, f of x, notice I'm taking a little shortcut now, I'm not writing times g of x. That's what I meant, Eventually, you'll stop writing that down. But if you want to write it down, you can. Now it's a FOIL. X cubed minus 4x plus 2x squared minus 8. Oh, I wish I wrote it opposite, but that's okay. Just going to put this in standard form, highest power first. And there you have it. I did forget, it said to state the domain. So just by looking at these functions, f of x is all reals, g of x is all reals. So with the first three operations, we didn't really change anything. So the domain's going to be all reals for each of these. The only time we're going to have a real issue is if our original functions have issues to begin with, or if we're doing something like Part D. In Part D, I'm setting up f of x divided by g of x. So I have x plus 2 divided by x squared minus 4. And I know I can simplify that. So the final function would be that. However, when we go to find the domain of this function, we have to be very careful because we have to worry about this original function here. And we have to find out what would make that, right? What would make that 0? And that's going to be plus or minus 2. So my domain is x can't equal 2 or negative 2. And there you have it. Little bit of review from stuff you did last year, a little bit of new stuff. But all in all, I think you guys will be fine with this stuff. Do your homework, and we'll see you soon. So long.